Hello, good morning, good afternoon, good evening, wherever it might be. My name is Sean and I'm delighted you joined us for today's ESPC community webinar. This webinar is part of Microsoft Fabric Week, proudly sponsored by Actors. Today I'm joined by Maria Moore, who will present traditional ML in the age of AI, exploring data science capabilities in Fabric and beyond. We love hearing what you guys have to say, so remember to join in the conversation about today's webinar. Our handle is at ESPC_community and our hashtag is hashtag ESPC25. Tweet us, tag us, and tell us what you learned. Don't forget to check out our Learning Hub, which is updated with the latest blogs, ebooks, webinars, and how-to videos. You can access and view the Learning Hub by visiting our website, sharepointeurope.com, and clicking the Content tab at the top. Don't let the learning stop here. Continue to keep up and stay ahead by joining us for our next webinar, Unlocking Business Value with Microsoft Fabric and a Data-Driven Culture with Ben Jarvis. This webinar will take place Thursday, May 29th at 11 a.m. CEST. For more information on this webinar, please check out www.sharepointeurope.com/register for webinars. Looking to expand your Microsoft Fabric skills? Join us in Vienna from the 15th to the 18th of September for the European Microsoft Fabric Community Conference. Experience 3 keynotes, 10 full-day tutorials, and over 130 plus expert-led sessions covering data engineering, real-time analytics, business intelligence, and data governance and more. Sessions are delivered by Microsoft experts, community leaders, and Microsoft corporate speakers. Enjoy hands-on workshops, valuable networking, and memorable social events. Scan the QR code to get your ticket and use code FabricWeek150 for €150 off the current deal. FabCon Europe tutorials are here. We're excited to launch a series of hands-on tutorials focused on the latest innovations and practical applications of Microsoft Fabric. Topics include Microsoft Purview, Power BI, data warehousing, Fabric data agents, SQL databases, and more. Learn directly from experts and gain real-world skills that you can apply immediately. Use code FabricWeek150 to get €150 off the current deal. Limited time offer. After the webinar, we'll have a questions and answers session. Type any questions you might have in the questions box. Questions will be selected and answered at the end of the presentation. This webinar will be recorded and added to the Resource Center, where you'll be notified by email when it is available. And now I'm going to pass you over to today's webinar presenter, Maria. Hello, Maria. Thanks for joining us today.
Hi, thanks for having me. So I will share my screen.
Yeah, perfect.
Let me know if you can see something.
Yeah, I can see your screen. Yeah.
Perfect. So hi, everyone. Good morning, good afternoon, good evening from wherever you are joining. Welcome to my session on traditional machine learning in the age of AI, exploring data science capabilities in Fabric and beyond. My name is Maria Moore. I'm working as a data and AI engineer with Ubungi for 6 years now. Ubungi, who are we? We are a rather small consultancy company, a Microsoft partner, Fabric featured partner, and we are specialists for cloud-based data analytics and AI solutions based in Hamburg, Germany. And we've been working with Fabric for quite a while, actually, since its early days when it was still under private preview. And we are quite excited to see how the product evolved since then, how it is used, by us, by our customers, and also by the community. So I'm really excited to be here, actually. Thanks again for having me. So the topic for today is traditional machine learning in the age of AI. And let's be honest, right now, Gen AI is king. So large language models like GPT, Claude, and Gemini are everywhere. Agentic frameworks like AutoGen, LangChain, semantic kernel are really the terms that people talk about right now. AI is writing code, answering emails, even making decisions. And with co-pilots integrated across the Microsoft stack, you really feel like Gen AI is everywhere. And by the way, I did use AI to generate all the images that you will see in my presentation. So having said that, the question is traditional machine learning still relevant? Do we still need to train classic models like regressors, classifiers, or time series predictors? And my answer is a clear yes. So traditional machine learning is far from dead. It's still the engine behind many critical applications. And while Gen AI does get the spotlight. To be fair, traditional machine learning continues to actually deliver business value. And let's look at some real-world examples. The first one is a company in the food service industry. So they are struggling in planning for staff and resources. So what the solution is actually a machine learning model to analyze historical sales and operational data, which incorporates influencing factors like weather, holidays, local events into forecasts and enables forward-looking planning across inventory and staffing. And the business value here is clearly a faster and in particular data-driven decision, because before it was more like a gut feeling. And applying these models then result in an improved budgeting and a better planning for resources and staff. And this is really a classical use case, a classical machine learning, traditional machine learning use case for time series forecasting. So the sales data, the data points, there are data points in time, and we want to forecast one of these data points for a future point in time. So we want to predict how much sales amount will we have in the next week in order to be able to plan for staff and resources. So a classical machine learning use case. The second one is a predictive maintenance example in the wind energy sector. So there, unplanned turbine downtime causes energy production losses and high operational costs from emergency repairs. And what the solution here again is a machine learning model to analyze sensor and maintenance data and to predict failure of key components and to enable proactive maintenance then. And the development of such a model then reduces, ideally, maintenance and operational costs and results in a smarter asset management. And again, this is a traditional machine learning problem, a classic machine learning problem. One way to model this is, for example, using a regression model to predict the remaining useful life. So to predict how long it will take until the machine fails. So classic machine learning problem. Third and last one, churn prediction use case in the banking industry. So the term churn prediction means predicting which customers are likely to stop using a product or service. So in our case, the question is how or which customers are likely to close their bank accounts, to switch to another bank. And the solution here again is a machine learning model. A machine learning model to predict that risk, to predict or to surface at-risk customers to frontline teams so that they can proactively approach them. And the business value here is, of course, to reduce customer churn, but also to have a more focused retention campaign so that promotion is really only applied to these at-risk customers and not to just a bunch of customers. So again, a classic example for a machine learning problem. This is typically a classification model. So we classify the customer as very likely to leave the bank, to churn or not to churn. And this is actually the example that I will also use in my demo today to demonstrate some of the machine learning capabilities within Fabric. So how would this go? The customer relations team suspects a trend. We are losing long-term customers who were previously engaged. And they approach the data science team. So they ask the data science team, can you help us predict churn before it happens so we can intervene? And what particular, they want to predict which customers are likely to leave within the next 30 to 60 days and flag them for proactive retention outreach. So they want to proactively play or apply promotion to these customers that were flagged as very likely to leave the bank within the next 1 or 2 months. And in this use case, the data already lives in Fabric. So Fabric is used as the data platform for analytical use cases. So the data science team can start directly in Fabric. They can look at the data and that they can try things out. They can do some prototyping. And what they do is they actually use AutoML in Fabric. And I will show you this in a minute. First of all, what is AutoML? Automated machine learning. It is a concept that helps you build machine learning models automatically, so to say. So how does it work? It works by trying out different kinds of algorithms that might be suitable for your machine learning problem and different kinds of combinations of parameters. And for each of these sets of algorithms and parameters, it trains the model then, and it identifies the performance of these models by collecting some metrics, some model metrics. And then it compares the different performances of these different models, and then it picks basically the best one, best model, best suited for your use case and for your data. So that is in general, the concept of AutoML. And in order to realize that concept, there are frameworks, there are libraries, packages available that you can use programmatically to realize that AutoML concept then. And they are also available, or there are frameworks available in Fabric that you can use for AutoML. So let's see how this works. I have actually recorded this demo yesterday, mainly for two reasons. So firstly, in order to see something meaningful, you have to run the AutoML run maybe more than just a minute. So you, as I said before, this AutoML concept, it tries different sets of algorithms and parameters and trains the model for each of these sets and then compares. And in order to have not just one or two different runs, you would need to run this whole AutoML trial more than just 1 or 2 minutes. So this would not really be suitable for a live demo today. And to be honest, secondly, I don't really want to tempt with the demo code today. So I will play this video, but I will explain along this video what is happening and how it really works. So let's start the video. Or maybe first of all, where do we start? We start in Fabric. So in Fabric, I have a workspace, and within that workspace, I have a lakehouse where my data is stored. In that lakehouse, I have one table that contains information on my customers. So that contains information on, for example, the age of the customer, the account balance, information on whether or not the customer is active, information on whether or not the customer has a credit card, an estimated salary, and also a label which classifies that customer as likely to churn, to leave the bank within the next 1 or 2 months or not. So we have labeled data, we have data where we have an exited column that says, is the customer likely to churn or not? And additionally, we have a so-called experiment item in Fabric. And you can start an experiment run. This is one of these items from the data science workloads in Fabric. You can start with a run by starting with a template, starting with an existing notebook or writing a new notebook, or you can start with AutoML. And if you start with AutoML, I will show you what will happen. So let's play this video. So from the experiment item, I click on Start with AutoML. And what is happening now is a wizard is opening up that is guiding me through the process of creating that AutoML trial. So remember, I said that concept, in order to apply that concept, I have frameworks, libraries, packages, so I need to write code. But in Fabric, I don't really need to write code because I have that wizard that is guiding me through the process and then in the end generating that code for me. So first of all, I would need to specify what data I want to train my model on. So here the data lives in a lakehouse. As I told you before, we have one table that is called DF customer, and that table contains information on our customers. As I said before, we have here age, we have number of products, credit score, balance, estimated salary, also the exited column that I mentioned before. And this data I want to use to train my model now. Secondly, I need to tell the AutoML framework which kind of machine learning problem do I have at hand. So I said before, you don't really need to choose the algorithm that you want to use to train your model yourself. AutoML is doing that for you, but you need to put some information on what kind of machine learning problem it is in order for AutoML to be able to pick from the libraries, from the algorithms that are suitable for this specific machine learning problem. So in this case, in Fabric, what we have is we have basically 3 kinds of different machine learning problems that are supported with AutoML. We have classification, we have regression, and we have forecasting. And for the customer churn example, this is a binary classification problem. We want to classify whether a customer is likely to churn or not. So 0 or 1, right? So we choose binary classification here. And that way, AutoML knows already what kind of algorithms are suitable for that type of machine learning problem. Next, to set up the training data, I need to specify from my data, from my delta table, what column is the column that I want to predict on. And I told you before, this is the exited column that is stored, or that stores the information of the labels, basically, whether the customer is labeled as to be likely to churn or not. And then I can specify some other things, map some input columns, specify whether I want to have featureization enabled, and then finally I can define the names of the items that will be created for me. So I said that before, if I go through that wizard, the code that uses the AutoML frameworks is generated for me, and that code is presented basically or executable in a notebook. So I give the notebook that will be created then, that Fabric notebook item, a name. And once I do that and continue here and then finish that whole configuration setup, then this is exactly what will be happening. So a notebook, Fabric notebook, is created for me with all the code that I need, with the packages that I need to enable AutoML. And you see here on the left-hand side that the lakehouse that my data is living in is automatically attached as default lakehouse to that notebook. And what I do here first, actually quickly, is I increase the time budget. So that is the total running time in seconds. So the total time that the AutoML trial takes to try out these different kinds of algorithms and parameters. And per default here we have 2 minutes, but I increase that to 6 minutes in order to have a few more different trial runs that I can show you later on. And then when I run all the cells, I will walk you through the cells and explain a little bit what's happening. So first of all, not only code is generated, but also information with it. And this is really nice, I think. So you have a markdown cell at the very beginning that is giving you some general information on automated machine learning, on AutoML in general, on the framework that is used in Fabric, which is the FLAML framework, so fast and lightweight automated machine learning. And you will have an overview already over the steps that are taken within this notebook. So Markdown cells, code comments is also automatically generated in order to help you understand that code that you have not written yourself, right? But that was generated for you by Fabric, basically. So the first step then in this notebook is really to load the data into your Spark session, basically into your notebook, right? So the data is living in the lakehouse, and we need to import that data first into a data frame in order to make use of it. And in Fabric, we can then use the built-in visualization features like the display function to then also have a look at that data that we loaded into a data frame. So here we see again all these features. And also the column that we want to predict on. So we can have another look at our data that we will train the model on. Then the next step, the second step, is some data pre-processing. So for example, some functions are created here to fill null values. And then a very important step is taken. The data is split into train and test data set. So that is what you always need to do when you want to train a machine learning model. You don't want to train it on the whole data set, but you want to train it on only parts of that data and leave some other parts out so that you can then, when you want to predict, test the data, test the model, you want to do that on data that the model has not seen while training before. So splitting the data into test and train data set, and again, this is all generated, right? This is everything generated from this wizard, so I do not have to care about this. So the training data set here again is displayed. We can have another look at that. We can see the that is part of the data set, only the ones that we want to use for training. And then the interesting part comes into play, the actual training of these different models, so the actual run of the AutoML trial. And here another important feature of Fabric, or in general a framework that is an open source framework, comes into play, which is MLflow. So MLflow is an open source framework, but it is only also available in Fabric, and it is used to track experiment runs and model versions. So I told you before, what is AutoML doing? It tries out different algorithms, different sets of parameters, and trains the model with these configurations. And then it looks at the model performance. It decides how well performed which version of the model. And then it compares the metrics and decides which is the best performing model. And in order to track and to log this information, so the information on the different model performances, on the different metrics, what kind of parameters have I chosen there, to do that, you would use MLflow. So this MLflow framework is used here to initiate the experiment, and within that experiment, automatically these model metrics are logged. And what is really nice in Fabric is you can have a look at that also afterwards, and I will show this also in a minute, in some visual interface. So there's a UI, there are dedicated items in Fabric that you can then also use to visually see the performance of the different runs and of the different model versions then in the end. So MLflow, a really important feature that is available within Fabric for model tracking, model monitoring, model lifecycle management. And then in the next step, the actual AutoML configuration is set. So there are different different settings that you can set here. For example, the time budget parameter that I just increased to 5 minutes, but there are other things that you configure. For example, the maximum iteration is set to 10. So that means the maximum number of different versions, different sets of configurations, algorithms is 10. So it will not, the whole framework will not try out more than 10 different versions, 10 different sets of configurations to train a model. And then once this is initiated, then the actual run is started using, again, this MLflow framework. So MLflow, because we use MLflow, we make sure that the outputs of the training runs, the model statistics, the metrics are then logged automatically into, here in Fabric, it is made visible via this item that I will show you later on. And this is here where the actual training happens. So I have speed this up a bit. This takes, I think, around 6 minutes. And what is happening here is we use the training data set to run this AutoML trial. And within that AutoML trial, a lot of, in this case, 9 different sets of algorithms that are suitable for the binary classification use case and for your data are used to train the model, and the model statistics, the metrics are logged then, and it is then compared which of these versions performed best. So, and we can see that here also in the output you can see the different runs and the different child runs for this kind of experiment. But I will show you this later on in the experiment item as well. So now we have these different experiments. We don't have a model yet, but this is happening in the next step, in the step 4. So we again use ML flow, the register model function, to now choose or to register one of these experiment runs to provide the model, to serve the model in order to make predictions then to new data. So we register the from the AutoML run, which was the best version of these configurations, so the best experiment run, we will register as a model with this code cell here. And then once this model is registered, you can then programmatically use that model to do inferencing, to do the prediction, right? And we would do that on the test data now. So the test data we use to actually predict whether the customers stored in the test data set are likely to churn or not. And the results are here stored in a data frame, and we can then automatically, or not automatically, but by executing that cell here, save that data in our lakehouse. Because we are working directly on the one lake, we can directly write the predictions back to our lakehouse, to our one lake, in order to use it then later on for visualizations, for example. So if I refresh here the lakehouse, I can see that there's a new table created, the DF customer prediction, which is containing then the model results applied to my test data set. And again, up to this point, I have not written any line of code, right? Everything was created for me. The only thing I had to do is I had to specify what data I want to train on and what kind of machine learning problem that is, and then that whole notebook was generated for me. Of course, I can use that as a starting point and I can do adjustments, right? That is, of course, possible. So let's look at these experiments again. So I have told you before briefly that additionally, I mean, the model or the training, the metrics and model statistics for the training runs is logged. And in Fabric, you get, I mean, automatically via this ML flow framework. And in Fabric, you additionally get also items, Fabric items with it that provide a visual interface that you can use to basically compare these different runs. And you have a link in your notebook here also to jump to that item. And this will basically open up the item, the experiment item that I have used earlier on to initiate that AutoML run. So if I refresh, I mean, beforehand that was empty, right? There was nothing in it. If I refresh that item now, I can see that there's content. There's actually one trial run with 9, I think it was, 9 child runs. So each of these 9 child runs represent one set of configuration, one set of algorithm that AutoML was trying out during that AutoML run. And I can also switch to the run list and here compare these different runs with one another. So if I select all these runs here, I see a table with all the model statistics, but I also see some pre-built visualizations. So for example, I see a visualization for the best validation loss, which is a model metrics that gives you information on how well the model performs on data it has not seen before, so on the validation data set. Or a different model statistic here is the ROC AUC, which is a specific statistic or metric for classification. It gives information on how well the model can distinguish between different classes. And you can also see on the right-hand side there are even more metrics and different parameters that were tried out and used during these different experiment runs. And you can also adjust the visualizations here. So you can change, for example, the iteration counter to, so the middle visualization to show instead the trial time, so the time that the algorithm took for each of these experiment runs. So this is a pretty cool feature in order to compare different experiment runs and to visualize that how the statistics were behaving and which of these experiments was actually the best one. So now I went back to my Fabric workspace. So what do we have here? We have that lakehouse, right? We have the experiment that initially created. We also see the notebook that was automatically created via AutoML. And we have additionally another object, another item that is of type ML model. That is also one item that is in the area of the data science workload in Fabric. And that was also automatically created via code when we executed in the notebook that cell that saved the model, that saved the best experiment run as a model, registered the model. And we get here also that UI component with it, which is the ML model. And if we open that one, it does look a bit similar to the experiment item, actually. So you see here the different model versions. So for this one model, we have now one registered version because we registered this one experiment run as one version of this model. If we would register a different run as a second version, or maybe train a different version and register it, we would also see here more than just this one version. But for now, we only registered this one version. But in Fabric, you have this version control of your models then here directly integrated by using this MLflow framework and this UI component here to see the different versions. From here, you can also see which experiment and which experiment run was used to register this model. So here, apparently, the child item 6 was the best performing option based on these metrics that were stored. And you can also switch to the model list, which shows you also a comparison of the different versions. I mean, here we only have one version, so there's nothing really to compare, but in a real world example, you would maybe want to retrain your model on a regular basis, and then you can have different versions and compare your versions and switch from one version to another. What you can also do from this item here is, so as of now, we talked a lot about training, right? But what you can also do is the inferencing part from this UI actually. So the actual application of the model to data. So predict new customer data and predict whether they are likely to churn the bank or not. And there are two options. You can either copy this code here and integrate it into your own pipelines and workflows, or you can also use again a wizard. So if you apply this version using that wizard, you will again be guided through the process of defining a couple of things. So defining what data you want to predict on. So in my case, I just for demo purposes selected again this DF customer. Of course, in a real world example, you would have new data, not the data that you trained on. But if you select that here, you can specify the input columns. You need to specify the output, so the table name that you want to use for your predictions to be saved in, and also the output column, so the column that you want to store the predictions in. And if you do all of that, then the code is generated again for you. And at this point, you could also define the name of the notebook, and the notebook would be automatically created for you containing that code. And then you could integrate that notebook into your ETL processes in a data pipeline, for example, to automatically predict data that is coming in. So another cool feature that you can use in order to apply that machine learning model then that is registered in Fabric without the need of writing any line of code. So pretty cool, actually. And lastly, if we go back to the workspace, what is also very nice is that we are working directly on the one leg, right? We are in Fabric. We didn't have to leave Fabric at all in order to train the model, in order to apply the model, in order to do the data preparation beforehand. So that is all part of Fabric. So we didn't have to copy the data somewhere else in order to train a model then and use it then. So, and because we have just stored that predicted data directly back to a lakehouse, we could from here now create a semantic model, create a Power BI report on top of that, and generate insights based on that model. So we could then identify the customers that are likely to churn within the next 1 or 2 days, visualize them, and communicate them to the customer relations team, for example. So that was my demo. So we have already seen very early on in the talk a lot of different machine learning features. So we have seen notebooks for data pre-processing. We have seen ML flow for model tracking and versioning and these experiment and model items. And we have also seen how to apply a registered model. And this, I mean, I speed up in between a little bit, but altogether this maybe took, I don't know, 15, 20 minutes. So that is pretty cool, right? So that's great. The customers relation team now is really happy. They have a model now. They have predicted values. They can use this now in production, right? Well, the data science team might have a word in that, because what the business actually wants is, or what they're actually asking for is maybe even a daily churn risk score to be integrated also in external systems like their CRM system or Power BI dashboards, highlighting at-risk customers by segments. And what they are additionally maybe asking for, even if they maybe don't know it yet, is like a regular retraining and recalibration of the model to keep it fresh, right? And they also would want to have some traceability, some monitoring of the model performance over time. And these requirements actually call for a professional machine learning setup and not just a one-time experiment. So what is a professional machine learning setup? I have tried to collect some of the requirements that, in my point of view, are necessary for an enterprise-grade professional machine learning setup. So what do we have here? We have scalable and modular training pipelines with support for automation and reusability. So you don't want to just train your model once, you want to be able to retrain it. So you need some scalable and modular training pipelines. You need to have some model versioning, right? Like we have seen in Fabric with ML Flow, model versioning and registry. You would want to have the possibility maybe even to monitor your resource usage and compute cost optimization. You would maybe want to have even an automated retraining workflow triggered by data changes. So if data changes and the model performance decreases, you would maybe want to retrain your model and even have that automatically triggered by these performance changes. Model monitoring is also a topic, right? I mean, that is necessary in order to have this automated retraining. Regarding inferencing, you would like to integrate inferencing into ETL processes, maybe even for not only for batch scoring, but also for real-time scoring. And maybe you would want to serve that model as an endpoint or API to serve predictions in business applications. CI/CD pipelines for machine learning is also a topic that is relevant in a professional machine learning setup. So model testing, the ability to bring the model from a development stage to a test stage to a production stage, to roll out maybe different model versions, also maybe not completely, but gradually. So there are different rollback strategies that might be interesting for you. All these things are relevant when you talk about a professional machine learning setup. And also reproducibility of environment, that is also a necessary condition in order to bring your machine learning models and your machine learning framework to a production environment. So in the demo, we have already seen some of the requirements are met in Fabric, like model versioning with MLflow, right? Or inferencing, batch inferencing we can do with Predict. And I will try to show you which of these requirements on a professional machine learning setup are met in Fabric, and also try to highlight which are not or not fully met. And we will also see if that is the case, and if you really aim for a professional machine learning setup, what alternatives or additions you have in the Microsoft ecosystem. So up to this point, we have already seen a lot of different machine learning features in Fabric. And in the next couple of slides, I will try to put this a bit into perspective. So to give you a bit more structure maybe. And to do this, let's have a look at typical data science process. How does a typical data science process look? So independent of any tooling, right? You could say that it starts, at least it should always start with the problem formulation and the ideation. You do need a use case. You need data, of course, but you need to know what exactly you want to achieve, what exactly you want to predict. So for the example of the customer churn prediction, do you want to focus on improving your promotion strategies, for example, or do you want to focus on really making sure that no customer is likely to leave the bank? These kinds of questions you have to ask yourself, and in order to do that, you have to look at your data and to think of your actual use case. So that is really always the first step, the problem formulation and ideation. The next phase is then the data discovery and pre-processing. So you have to look at the data, you have to pre-process in order, for example, very simple things like data types, but you also want to maybe see if different factors are relevant, if different features are relevant for your use case. Maybe you want to integrate these. So for the sales forecasting, for example, you would want to integrate weather data or public holiday data into your data set as well. So this is all covered in that data discovery pre-processing phase. And then after that, the actual experimenting is happening. So actually what also was automatically done using AutoML can also be done manually, basically. So you choose, based on your machine learning problem, you choose an algorithm that you think would fit this machine learning problem well. And you choose to set these parameters that are relevant for that algorithm in a certain way. And then you train your model. You evaluate your model on data that the model has not seen while training, and then you compare, and then you do that again, tweak maybe some parameter, maybe use a different algorithm, and then compare the model metrics, the performance of the models with one another. And then once you are satisfied with the model performance, you can you would then register your model and make that model available for inferencing, for applying that to data. And that is actually the enrich and operationalize phase, to actually use that registered model then on data, on new data, to predict then, for example, in our use case, the customers that are likely to leave the company, leave the bank within the next 1 or 2 months. And then the last part is generating the insights based on that prediction. So in this phase, you would want to visualize your predictions, and you want, basically with the aim of taking actions out of that, right? So you would want to, in our use case of the churn prediction, you would then want to decide on which customers do we play promotion, or do we apply promotion on, which customers do we approach directly, maybe via a phone call or these kinds of things. And in Fabric, you have features to cover all these 5 phases of an end-to-end data science process, actually. And yeah, this I'm showing you this component diagram. I'm sure a lot, or maybe even all of you have seen it before. If you have seen talks on Fabric, if you have read any documentation or blog posts, this is the main component diagram that is used when talking about Microsoft Fabric. We have the one lake as the central data store, the managed data lake, and then we have these 6 workloads on top of that work directly on the one lake. And I'm showing you this picture because I want to point out that one of these workloads is dedicated to data science. So data science, the data science workload in Fabric allows users to build, deploy, and operationalize machine learning models directly in Fabric, directly on data that is stored in the one lake. And how this looks like in particular, we have already seen in the demo, right? We have already seen a lot of these features in the demo. And in the next slides, I will kind of summarize what we have seen and put this into each of these steps in an end-to-end data science process. So if we start with the problem formulation and ideation, this is actually a quite important one, I think, and not to underestimate. Because it's quite important that business users, so the teams that actually formulate this problem, and data professionals like data scientists collaborate together in this early phase, I think, because in our customer churn prediction use case, for example, the question could be, is it important maybe to only predict clear high-risk customers in order to have a more focused promotion campaigns? Because maybe the promotion is quite expensive and we only want to roll that out to really clear high-risk customers. Or is it more important to definitely predict all at-risk customers, to not lose any customers? And whether or not it is one or the other, this is influencing how we model, how we train the model, because we would optimize on different kinds of metrics in that model. So it's really important to that these two teams basically work together and also in this early phase. And their Fabric is a really perfect platform, because it is that unified platform where you can seamlessly collaborate across different roles, and where data scientists, business users work all on the same platform, can look at the data, can discuss the actual problem, can ask questions on all these things. All right, so that is the first step, basically covered in Fabric with all these functionalities. For the data discovery and pre-processing, we have also seen that in the demo. You can interact with the data in one lake directly, right? With the lakehouse is connected to the notebook is connected to a lakehouse, and you can directly interact with data that is stored in that lakehouse, so that is stored in one lake. You can do data cleansing, transformation, exploration, featureization by leveraging built-in experiences on both Spark as well as Python, actually. You can use pre-installed open source libraries for visualizations. You can install custom libraries as well. So everything is available here in this notebook experience. And you can also use the data wrangler to generate code for you. So that, again, tries to enable people with less code experience, I would say. So it is a tool that you can use from within a notebook, where you have an interface and where you can specify what kind of transformation you want to do on the data. And then the code to actually execute that information, that transformation, is generated for you. So again, a low code functionality to generate or to do things in Fabric, actually. And here, in this case, to explore, clean, and prepare the data. So also covered in Fabric. Then we have the experiment phase. In the experiment phase, what is really the main feature in Fabric, or one of the main features in Fabric, is ML Flow. And I've talked about this before. So ML Flow is used to track experiment runs and model versions. You have this automatic logging in place. You also have this model and experiment items in Fabric that I showed you. And these are all features that are relevant for that experimenting phase then. And for actually applying the model, doing the scoring, doing the prediction, in Fabric, we can do batch scoring with that predict functionality with both code first and low code options that I also showed you in the demo. And you can also schedule predictions via pipelines. So you can schedule, you can execute these notebooks that run the prediction code from within the data pipeline, and that way you would integrate it into ETL processes that are living in Fabric anyways. And last but not least, the insights, well, Power BI, right? So we have that very easy possibility to write predicted values back to OneLake, and then you can build your Power BI reports, use even the direct lake mode that consumes directly data from your lakehouse, live data, so to say, to visualize your predictions and to then gain insights and to take actions on your predictions. So all of these features that we have seen cover actually these different steps from an end-to-end data science process. So to summarize again here is for the problem formulation and ideation, you have Power BI, of course, but you have also the possibility to look at the data from a lakehouse. For the data discovery pre-processing, you have these notebook experiences and the lakehouse. In the experimenting phase, you would use ML flow and machine learning frameworks to train your model and to track your experiment and model runs. And then to use registered models, you can use the batch prediction also on a code basis and store the predictions directly in OneLake and use then direct lake mode to visualize that data into Power BI. So my first conclusion is Fabric is actually also king. So everything is in one unified platform. Fabric helps the collaboration between business teams and data professionals. It empowers business user and also data professionals to do analytics and also end-to-end machine learning. And I mention here specifically the business users because there are so many low-code options in Fabric that you can use to generate code actually for machine learning purposes. And what I have not mentioned so far at all is Fabric is AI powered everywhere. I have not mentioned this because today it is about traditional machine learning, but AI is also relevant for these aspects in Fabric actually, because you have the Copilot that is helping you to write code. You have AI functions that is helping you to pre-process data, and you have data agents that is answering questions or giving you insights on your data, on your structured data that is stored in OneLake. So also a very important topic when we talk about data science and Fabric, but not the topic for today because we don't have that much time. Okay, coming back to my what is a professional machine learning setup slide, I want to quickly actually put the Fabric icon on the topics here that I believe are at least partially supported in Microsoft. So let's start with the scalable and modular training pipelines. Yes, we do have data pipelines that we can use to execute code via notebooks. We have the ML flow integration, so that is at least partially supported, definitely. There is no full MLOps pipeline SDK, but you have the possibility to execute things in pipelines and notebooks. Model versioning and registry. So yes, you do have ML flow tracking, and we have that integrated model items. So that is there. The promotion between different environments, approval workloads, Stage tagging, these kinds of things are not available, at least not available yet. Inferencing and to ETL tools, yes, fully supported for batch inferencing, not supported for real-time inferencing. Model monitoring, track performance, drift and data quality, yes, this is covered by MLflow. There is no automated monitoring available in Fabric, but with MLflow you can track model performance. And reproducibility, I mean, I would say this is limited support. We have the MLflow integration, we have within the notebooks and pipelines, which are version controlled, but you don't have a support for custom containers or Docker images as you have in other tools. There's also no automated retraining, no deployment of endpoints or APIs that can be directly used outside of Fabric. There's also no CI/CD feature for the machine learning models, and you can also not really manage your own compute instances in Fabric because everything works on the Fabric capacity. There is actually a product within the Microsoft ecosystem that is covering all of these requirements for professional machine learning setup, and that is Azure Machine Learning. So Azure Machine Learning is a dedicated tool for these kinds of things. Machine learning as a service is a dedicated tool for machine learning workloads. And it is a PaaS solution, a platform as a service solution. Fabric is a SaaS solution, software as a service, so you don't have to provide the infrastructure yourself. For Azure Machine Learning, you do have to do that. But once you have that, you also have an interface, a visual interface that you work on, where you can train models, where you can have or do model deployments as APIs for both batch and real-time inferencing. You have ML pipelines, you have the full ML ops tools for versioning, tracking, CI/CD for ML projects, different rollout strategies. You can configure and manage compute. You even have a feature store, which is quite new actually. You have data labeling tool. So really the full-fledged machine learning service platform for a really enterprise-grade professional machine learning setup. So does that mean we don't use Fabric anymore if we want to do data science? Well, it is not necessarily one or the other. Both services coexist and integrate in one another. So you can define, for example, data stores in Azure ML that point to Fabric OneLake. So you can use the data that is stored in OneLake. You can use Fabric as your one data store, as your one data platform, and then use that data that is living in OneLake for your model training in Azure ML. And on the other hand, you can serve then your models in Azure ML, have that whole model lifecycle management in Azure ML, and use the endpoints in Fabric for inferencing. And my second and last conclusion is then really Fabric and Azure ML work quite well together. So I mean, the question is when to use what. Definitely use Fabric as your central place for all data workloads. Also use the ML features within Fabric as an extension for data analytics with data science. If you want to prototype machine learning models, if you have a smaller team, if you have a semi-professional setup, use the end-to-end workload, the end-to-end Fabric workload, data science workload in Fabric. But if you want to fulfill all these requirements on a professional setup, if you want to really move to an enterprise-grade MLOps setup, then use Azure ML together with Fabric. So store the data in Fabric, or Fabric as your data and analytics platform, Azure ML as your MLOps platform. And if you do that, not only the business team, but also the data science team will be happy because they have a professional setup that allows, for instance, for automated monitoring, retraining, inferencing, and everyone will be happy. And that is my last slide, actually.
Perfect. Thank you, Maria, for a great presentation demo. So we'll get into questions part now. So the first question is, so you would recommend create code in AutoML and then optimize it?
It depends. So it depends on your experience, I would say. If you want to prototype, I mean, if you start with a machine learning problem, it is a great start to use AutoML because you don't have to configure anything. You can just generate that code and train your model there, and then you have a benchmark model that you can use to compare with. If you then later on really dig deep into the data, do featureization, and choose a more specific algorithm and really tweak their look in the data and tweak the parameters that you put into that algorithm, then you can compare that model training with your AutoML. I mean, AutoML is great as a first start because you don't have much effort to do that. But yeah, if you later on, you probably won't want to dig deeper into the actual frameworks, actual algorithms that you want to work with your data, and depending on your data science problem.
Perfect. And the next question is, what are the data row limits in Fabric?
I think I need a bit more context to that.
Yeah. Let's see if Mohsin right back. I'll just go to the next one. Hi, how do you choose the metric to evaluate the model? Example, IRAC, AU, or OC?
Well, the model, I mean, if you use AutoML, the matrices are tracked automatically, right? And we saw that in the setting. I'm not sure if you can specify it somewhere in the setting, and also in the ML flow settings. Maybe you can specify the metrics that you want to monitor. I'm not too sure actually, but out of the box, they are, depending on your machine learning problem, specific metrics are logged. So not 100% sure if you can directly define that and configure that for your ML flow configuration.
Perfect. So the next question is, can you feed the model to run every time a new event comes from event stream to event house and auto update its predictions?
That is a good question. I'm not too sure if there is already an integration between the real-time intelligence, like the event house objects in Fabric together with the models. I don't think so. I think as of now, this is really only limited to batch predictions, as I also showed in the presentation. So I'm pretty sure there is at the moment, no possibility to do real-time inferencing. But I could imagine this might change.
Perfect. The next question is, what is the underlying ML library used by AutoML?
So the framework that is executing that AutoML concept is FLAML. I had this also in my demo. And that is the framework, the library that is used. And when the AutoML run starts, it will use, I'm not sure what exact libraries it uses then to train the exact model. It depends also on the type of machine learning model and on the type of settings you define in the AutoML. But the overall framework to execute that AutoML trial is this FLAML framework.
Perfect. Next question is, which experience do you have regarding CU consumption for AutoML and Azure ML?
I cannot really answer that question at the moment. I would have to consult with some of my colleagues and get back to you on that one, actually.
Okay, perfect. So another question, how to expose the results via REST API?
Not possible as of now. So as of now, if you are only working within Fabric, you can only use that model from within Fabric, so use that predict functionality to predict data within Fabric. There's no possibility to expose the model as an endpoint to some other applications as you would have in Azure ML. In Azure ML, you can deploy a model endpoint, an API that you can trigger from outside, but in Fabric, this is not supported as of now, at least.
Perfect. We'll do one more question as we're running out of time, if that's okay.
Yeah.
Is that okay?
Yeah, sure.
Am I right in thinking the feature engineering would have to be done before AutoML to get these features all in one table of features and labels?
Yes, probably what you would do is you would, I mean, you saw that there was this one toggle of featureization that I used. So you can define that there is some featureization happening within the AutoML trial. But the thing is, you don't really see what is happening under the hood, right? You don't really see exactly what is what the framework is doing then. And what you would want to do probably is do the featureization, do the data pre-processing beforehand. As I said, AutoML is a great option to do some prototyping. But once you then actually start building your own model, you would start with the data pre-processing, featureization process as a separate process, and then based on that pre-processed data, you would do the model training and also the inferencing, right? So you would modularize these different steps of your machine learning process. So yes,
Perfect.
probably you would do that before the AutoML run.
Perfect. I mean, there's other questions in, but would they be able to directly message you privately on LinkedIn, or
Sure.
is it your best?
Yeah.
Perfect. So on behalf of the ESPC community, we'd like to send a big thank you to you again, Maria, for taking time out today to carry this webinar. Really appreciate it.
Thank you so much.
Perfect. So that's the end of today's webinar. You can find this webinar and more at sharepointeurope.com/resource center. Thanks again for all of you for joining us again, and I hope you join us again soon. Take care.
Thank you. Bye-bye.